So a die is rolled 5 times in this problem, and it's going to ask you about 2 different probabilities. So the question is what kind of probability problem is this? And the fact is, it is a binomial probability problem. We know this because, first of all, there are a finite number of trials. We are rolling the die exactly 5 times, which means that n in this problem is 5. That's how many trials we have. In addition, we know that the probability of rolling a 2 is constant no matter how many times you roll the die, that each trial, each roll is independent, so the probability of success, in this example, success will be rolling a 2, is 1/6. The probability of failure, which would be not rolling a 2, which is 1 minus p, is going to be 5/6. So this is the information that we have. What we need now is the formula for binomial probability. So let's pull that up. Here we go. We have the formula for binomial probability is n choose x times p to the x times 1 minus p to the n minus x. So let's fill in what we know. In this example, we said n is going to be 5. Now, x will change from problem to problem. In this example, it wants exactly 4 times. That is our x in this particular problem. So we have the combination of 5 things taken 4 at a time times the probability of success, which is 1/6 to the 4th, times the probability of failure, which is 5/6 to the n minus x, which is 1. So again, in this example, n is 5 and x is going to be 4. So let's go ahead and figure out what we have. The combination of 5 things taken 4 at a time is 5 times 1/6 to the 4th times 5/6. This is going to give us 25/6 to the 5th. Well, we go over to our calculator, and what we get is 25/7776. And if we do 25 divided by 7776, we get 0.0032. So that is the answer to the first part of the problem. Let's take a look at the second part of the problem. It says, what is the probability of rolling a 2 at least 4 times? Well, what that means is that we want to know what is the probability of rolling a 2 4 times. But since we're rolling the die 5 times altogether, we also need to consider the possibility that we roll a 2 5 times, because that's really what the word at least means. It means we could roll it 4 times, but we could also roll it 5 times. Now, the probability of 4 times we figured out in the last problem, right? So we're just going to put that in as 0.0032. That's what we already figured out. Let's use the formula in this case. If the probability of rolling it 5 times, our x has now changed to 5. And so we get the combination of 5 things taken 5 at a time times 1/6 to the 5th times 5/6 to the 5 minus 5, which is 0. We know that anything to the 0 power is just 1, so we're going to cross that off. We also know that the combination of 5 things taken 5 at a time is also just 1. And so we're going to get 0.0032 plus 0.0001, which is equal to 0.0033. And that is the probability of rolling a 2 at least 4 times, meaning 4 times and 5 times together.